Students, we have studied about electric flux. Now we are coming to the topic Gauss theorem. Gauss theorem states that the electric flux passing through a closed surface enclosing some volume equals to 1 upon epsilon naught times the charge enclosed by the surface. Let Q is the charge enclosed by the surface, then according to Gauss theorem, the electric flux passing through it is phi is equal to 1 upon epsilon naught into Q. We have already studied phi is equal to integral E vector dot ds vector. Therefore, we can write integral E vector dot ds vector is equal to Q upon epsilon naught. Or in this way, Gauss theorem may also be stated that surface integral of electric field over a closed surface equals to 1 upon epsilon naught charge enclosed by the surface. In order to prove this Gauss theorem, we consider a charge q situated at the center of a spherical surface. On this surface, you take a point P. Surrounding the point P, consider a small area ds and apply Gauss theorem. When you will apply formula for flux, then flux is phi is equal to integral E vector dot ds vector or EDS cos theta. For a spherical surface, electric field and area vector are always parallel to each other. Therefore, theta is equal to 0 and hence phi is equal to integral E ds. Substitute the value of E. After integration, you will get phi is equal to Q upon epsilon naught, which proves your Gauss theorem. Two important points about Gauss theorem are: if Gaussian surface encloses more than one charge, then we shall take the algebraic sum, means we shall consider the charges with their sign. In that case, phi will be equal to 1 upon epsilon naught summation of charge q. Secondly, if the charge is placed in a dielectric medium of dielectric constant k, then the flux passing through the Gaussian surface is given by the formula phi is equal to 1 upon k q upon epsilon naught.